Good afternoon, everyone. Welcome to the third and last working session for today's proceedings. This session will focus on a topic that is gaining increasing significance in the global security landscape, and that is growing power contestation in space. I extend my gratitude to our esteemed speakers for joining us to share their valuable insights on this complex and rapidly evolving issue. We are honored to have a very distinguished panel with us today for this important discussion. Be Dr. Ali Sarosh. Dr. Ali Sarosh is an experienced researcher and teacher in aerospace systems and technologies at the Department of Mechanical and Aerospace Engineering of Air University. He holds a PhD in space vehicle design and a master's degree in space propulsion technologies. He is the inventor of 2 design patents in hypersonic launch systems and rocket-based combined cycle engines. Dr. Sarosh has been appointed as the member of Technical Advisory Committee on Global Hypersonic Space Technologies by the American Institute of Aeronautics and Astronautics. Dr. Sarosh specializes his research in technology strategies and application for aerospace systems. He has extensively published journal works in space systems design, hypersonic technologies, development of sustainable space policies, strategies for nascent space powers, and counter space operation.
Dr. Ali Sarosh, sir, floor is yours.
Thank you, Chair. I have a confession to make. I'm the only mutant in this room, technologist and a scientist by profession and strategist by practice. So it's going to give you a different taste of how I look at things. It's not purely from the strategy point of view. It's also from how the technology is going to make a trajectory. So I'm going to talk about how the space contest is going to shape the technology in this world. And that technology is going to then transfer into the strategies that will evolve over the next couple of years. For the past 8 decades or more, we have seen that the technology and strategy have been steadily getting intertwined. We are now into the 3rd generation. From a technology perspective, I call it the 3rd generation of space contest. So I'm going to refer it to as Space Contest 3.0. This is an era of changing realities, an era where new powers have appeared and consolidated. There's a formidable challenger to the United States' existing space dominance, and something that US Department of Defense has already accepted in their State of Space Industrial Base 2022 paper, in which they have put China ahead of US as the possible dominant power, space power, by the year 2045, if not earlier. And that's a very important document. So this contest 3.0 is actually an escalating competition. It's a competition not just between major space powers, it's between nascent powers, it's also between the private entities. So there are too many stakeholders to this contest now. This is very different from what it used to be in the previous eras. And it's not about prestige, it's not about military superiority, it's about global dominance. That's how it's going to shape out. We want to create a situation where global dominance is established by a group of countries that form allies and team up in this domain. So when we talk about this thing, my hypothesis on this subject is that there are going to be 4 M's that are going to be very, very important. The first is money. The second is mining. Third is military. And the 4th is morphing. So I'm going to just touch upon all these things and connect them to the technology, how it's going to shape up. It's about money is about creating the space economy. Any space power that does not work on building its space economy will be fizzled out very quickly. The second is mining. It's about actually mastering the ability to extract rare celestial metals and also about celestial energy. And so celestial mining is going to be a very important technology of Space Contest 3.0. The third, of course, is military. But this time the military is going to be different. It's going to be counter space operations. The offensive ones will be very specific. It has to be lethal. It has to be cost effective. And it has to reduce the decision OODA loop, which is observe, orientate, decide, and act. The 4th thing is actually the biggest game changer, where people, their mentalities, their lifestyles, their business, the entire society is going to be morphed. So the space technology will be used as a tool for morphing our lifestyles. 4 elements are going to define the growth of space technology. So what are those technological domains that we should be looking at that will help us build these 4 M's? Actually, this thing is already on. So I'm just going to lump together, instead of going over individual satellites and launch systems, they are lumped together in the net outcomes. The first net outcome of technological domains is accessible technologies and services domain. So we see that there's a change. We are now having near contiguous constellations being built up and very fast. We have recently seen an increase in the launch capacities of all launch vehicles, and the most important is the space segment is now occupied by satellites, which we call as the ubiquitous satellites, so they can have multi-mission satellites. So from dual mode, we are going into multi-mission capabilities. The idea is, from the technological perspective, the idea is low cost, very high reliability, ultra low latency, and very high throughput satellites. The dual use satellite concept has transformed into multifunctional, software-defined, reconfigurable spacecraft that can change their roles and their missions while they are on the orbit. And that used to be not there a couple of years back. This has been tested on the GEO, higher orbit satellites, and now it has been transferred slowly towards the low Earth orbit satellites as well. The second technological domain that we are focused, that will bring about these four changes, is that the space powers realize the fact that they cannot remain relevant as long as their products, space products, and their space services are reliable. They can only remain relevant as long as their services are accessible, and most importantly, they are affordable. To make these products very affordable, they have realized that the baseline is to cut down the cost of launch services. So the launch services that used to cost about $25,000 per kilo to LEO about 10 years back have now come down to about $20,000, around $20,000 to $22,000, thanks to the private sector. And it is supposed to get down to about $25 per kg to LEO in the next 30 to 40 years. And that will be the time when your celestial services will be cheaper than your terrestrial services. And that will be when the entire spectrum will be controlled through the space. So that's what we are doing. And that's, if you look at it, since 2015, 10 new such launch vehicles have been added that are either fully reusable or partially reusable. We have SpaceX, we have Long March 8, we've got Blue Origin, Chooseway, we got Virgin Orbit, Rocket Labs, all coming up with these specific satellites for this very specialized purpose. The third technological domain is, of course, the military front. We've seen that there is almost continuous and fairly unimpeded development of transatmospheric hypersonic weapons. We've seen fractional orbit bombardment system again back in business. We've seen, we can see ASAT systems not going anywhere. We also have sustained directed energy weapons now emerging as a technology. Then we have, as Timothy was mentioning, the RPO satellites, and it's been tested with SJ-21, it's been tested in GEO, and now we would be looking at something happening in the LEO in the coming days. And then we have MTI payloads, we got tactical and celestial data links that are connecting the space to the, right down to the terrestrial surfaces. The military contestation is actually, the outcome of this technology is that the military contestation is focused on shortening the strategic and tactical decision time. And this is done by getting inside the OODA loop of your adversary. So the OODA loop is actually the key. And to get into that OODA loop, we need counter space technologies of the offensive type that reduce this decision time. And that's what the whole development will be focused upon. Now, these three technological domains actually result in certain very specific characteristics for this kind of a space contest. The contest 3.0 will witness, of course, this is a race, number one, for global dominance, as I already mentioned. So it's likely to see some kind of, some form of space colonization coming up in the next couple of years. There will be definitely resource extraction, and that means they're going to witness new forms of dispute over celestial resources. We will also possibly see some form of celestial delineation taking place between the space powers. And there will be a very stringent competition for global influence, because you have to morph people to believe that our services and our technologies are the best. So therefore, there's going to be a very different kind of a competition as compared to what we have seen in the previous two eras. On the second characteristic, this is celestial delineation. I've talked about why is celestial delineation going to take place is because there is going to be an energy rush. The world powers understand that the helium-3, the cold fusion energy source, is a vital source. We have already seen that energy relay satellite is already positioned at the second Lagrangian point of Moon. That's by China. and a possible lunar mining is on the card. It's already under development. Then we also see NASA preparing to send its asteroidal mining spacecraft to 511 Davida, and I can say the second one is probably 16 Psyche. So all these asteroids are on the card. The idea is that space contest of 3.0 is actually has a very major component in space mining. And so therefore mastering of new energy and resource supply chains is on the cards. And in doing so, the great powers are tacitly delineating the space territories. This is possibly how it appears to be developing. Then we have the arrival of the private space entities. This, to our side, is actually the game changer. The agents of bringing down the cost of space operations are private sector and not the public sector. What they have done is they are now producing complete satellite system. We have privately owned global SSA solutions, which is space situational awareness. We have LEO constellations, of course, privately owned. SpaceX is one example. And in August, China launched the Tianfan constellation. This is also privately owned. We have direct to home, direct to terminal services. We even have space mission operations controls, which are privately owned. We now have launch vehicles which are privately owned, things that were not even, could not even be thought of about 15 or 20 years back. The idea is that the characteristic of this contest is that the private space entities are not only cutting down the cost of the space products, they are actually easing the access of the availability of space services to the consumer. The World Economic Forum report, 8th April 2024, has also made this thing pretty clear. Space economy is likely to now reach $1.8 trillion mark, and that will be by 2035, in 10 years' time. This is almost 5 years ahead of their previous anticipation, because they believe that the private space companies have played a major role in lowering the cost, increasing the access to services, and bringing about, therefore, a societal level impact on around the globe. So these three characteristics, together with the three technology domains, how are they getting the life? So the lifeline is coming from certain factors. We call them the triggers of attenuation. So they are triggering and attenuating the contest. The first of these is the strategic alliances. There are new power corridors. From the unipolar, we've gone to the multipolar. From multipolar, we might be moving to a bipolar world. In that arena, what is happening is everybody knows, all the space powers know that there is no single know-it-all, do-it-all power that used to be in the 60s and 70s. In fact, there are going to be diversified power centers of space technology and space economy, creating their own ecosystems. And those ecosystems will have to be based on very strong synergy, very strong cooperation, and most importantly, the ability to contest their own adversary groups. So this is actually the first element of triggering. The second element of triggering is the economic factor. We have seen that $570 billion mark, which is 2023, took 20 years to reach this point. And it will take just 10 more years to jump this $570 billion mark to over 1.8 trillion. That's almost 4 times and half the period. So with this thing on, the private sector is all for grabs. So they are the ones who are actually now fueling the space contest 3.0, keeping it alive. The third thing is the trade wars between the countries. Of course, we've seen US and China trade war, and it has all the potential to engulf the space sector as well. We strongly believe that. The nanochip war that's been going on in Taiwan, has already exhibited that it can pitch superpowers in open seas. It can seize production of aerospace and automobile industry. So imagine when the space industry matures into a full-scale economy, private sector becomes stronger than the public sector space entities. The economic interest of private space entities can very well, and we strongly believe, can get space powers to pitch against each other in outer space. We say that trade wars can switch to star wars in just the spur of a moment. That's how it's shaping up. And the last thing is, which should be always natural, it's an organic factor, is the Thucydides trap. I'm a very strong believer of the Thucydides trap because we have the perfect recipe of Thucydides trap now in place. We've got a receding power, and we got a rising power, and we got a resurgent power all in the game. So the dynamics of Thucydides trap should not be removed from this whole picture. President Xi Jinping, in a 2014 address, has already mentioned this thing, and I quote, "We all need to work together to avoid getting into the Thucydides trap," unquote. If we build a CONOPS of this kind of a Thucydide strap, where great powers might at some point become belligerent in outer space, the capability to contest the adversary will not be on historic grounds. It will be actually on technological grounds. And there are 6 factors that we enlist in this case. The first factor I already mentioned is the speed with which the OODA loops will be running through the counter space operations. The second will be the ubiquity that the space systems will be offering to the allies. The third is the terrestrial permeation of the celestial services that will affect the people on ground, so making them loyal to a particular group of the space powers. The fourth will be the extent to which counter space technologies will be able to protect own assets and attack the aggressor if that situation arises. The fourth will be the robustness of economy, for how long the whole thing can be sustained. And the sixth item will be the cooperation between the allies, the degree of synergy that exists between the groups that form a particular space power. So based on this, there are certain, because we're sitting, of course, from that point, we can also have a look at how Pakistan stands in all this. Just a small 2 cents for Pakistan on this aspect. Pakistan is almost like any nascent space power on the rise. And of course, it's been a little erratic, the passage. Our best chances are at converting threats into opportunities. We know that we have a very limited space program at the moment. This is a threat itself, but it also offers 2 opportunities. The first opportunity is that there is practically very little in the space economy that we have done, so that there is a huge margin. And if we can tap on the potential of space cooperation, then we can actually build our space economy from ground upwards. Secondly, a smaller space program also means a smaller threat matrix. And I've given a talk on this at a previous event. So that means lesser commitment for military space tech as of this moment. This will leverage more economic freedom to build a civil commercial space program. So how to get into that space program? Pakistan might need to correct its strategic alignment in the realm of the growing space power contestation. There are 3 things we should do. First, we should reassess our national space policy. There are certain shortcomings there. We need to first effectively align the space policy with UN's Space 2030 agenda. We've already made a commitment there, but there is no mechanism mentioned inside. Secondly, we should propose a workable mechanism for civil corporate setup to be working within the space sector. We have already shown the commitment for this also, but there is again a missing link inside as far as the mechanism is concerned. Then we need to reduce reliance on purely on the national space agencies for sustaining and developing commercial space program. In fact, we need to promote and support corporate sector to be doing this job for us, and they can get in touch with the global space companies because there are no regimes in the civil sector. So you can connect with these companies very easily. Our objective as such should be to become a credible continental space power in the next 4 decades by developing a consumer-oriented space economy, one that is based on public and private or private-public ownership for providing 4 core services: celestial broadcasting, celestial internet, education, GIS, and very importantly, ultra-low latency telecommunication, because our telco sector is probably the best we have at this moment. It's only through these people-oriented projects that Pakistan can accrue true benefits and resist the temptation to become another proxy in the space power contestation within the great power competition. Thank you.
Thank you, Dr. Ali Sarosh, for such an elaborate discussion. It was actually quite different, but very enlightening. Thank you so much for that. Dr. Ali Sarosh, you have 3 minutes if you want to add or respond to something.
One point on this, again, coming back to the commercial space actors, we consider them as the game changers for the ongoing space contest. Unfortunately, within the non-proliferation regime, this is an issue because there are very limited legal frameworks right now covering the work of private sector. And this actually makes things very opaque. So possibly in the coming days or years, all the major space powers will have to get together with the nation powers, together with the private sector, to actually establish a well-defined legal framework of how they are going to function. We've seen SpaceX being, I guess, fined about $0.6 million recently for using a propellant that was not cleared by FAA. And these things are going to actually grow. And we, just as Dimitri was also mentioning about the possible proliferation of military military space tech. And anything could happen. So unless we do not have sufficient controls established in this domain, we might find ourselves in a quagmire-like situation in coming years, because they're going to be private sector, they're not public sector. So it's going to be difficult to handle them. So we need to put a well-defined legal framework, a mechanism, we call it the regulatory framework, and we let them grow, but grow with the certain regulations. Thank you.
Thank you so very much, ladies and gentlemen. Now the session is open for Q&A. We would appreciate questions. Kindly introduce yourself. And then as far as your question is concerned, please be very precise. Dr. Adil to start. I will come to later.
Thank you very much. I'm Adil Sultan. I teach strategic studies, which include politics of space at Air University. First question to James. Good to see you, James. You talked about Russian satellite, that space-based nuclear-based anti-satellite weapon. Russians might term this as nuclear-powered satellite. So, in your view, how Russia might use this nuclear-based satellite as an anti-satellite weapons, because it is not going to destroy only US-based satellites. Nuclear explosion in space is going to affect the entire space and affect all other countries. Juliana, I'm very fond of your podcast from Rusi. I heard somewhere you drew comparison between geopolitics and astropolitics. Like on geopolitics, we work on geography, and in space there are orbits. So, what are how do you compare these two? How this competition you can compare with geopolitics and astropolitics? Dr. Sarosh, for you, thank you very much for this presentation, which was enlightening in a way, some of the technical issues that you explained to us. And the role of private industry. Elon Musk now controls more than 2/3 of satellites. So that's the influence they have. And the low Earth orbits, they have a limit. If private industries and other countries, they start to, as they're sending thousands of satellites, eventually there would be saturation. How countries like Pakistan are going to be affected in that term, one. Secondly, you talked about celestial mining. Now, this is very interesting because everybody who has the potential, they are rushing to moon and to, as you said, also for resources. Once there are commercial interests, then definitely major powers, they will have the military presence over these celestial bodies. Already, Toyota Buggy is working on something that humans can stay for a couple of weeks over there, and some countries are attempting to build bases in the future. Do you think that kind of militarization on celestial body is going to be there once the mining or the commercial interests grow of these major powers? Thank you very much.
Thank you, sir, for your questions. I think we'll have a round of questions. Next question is from Mr. Zahir Kazmi. Sir.
A question to all the speakers, two common points. The first one is that what would potentially prevent the space powers from launching a verifiable initiative or a treaty that bans all anti-satellite weapons rather than just calling for a direct assent weapons ban only? That's my first question. And drawing from what James earlier said, asking Dimitri to define a space weapon, since all the speakers, I assume, agree that we should aspire for prevention of arms race in outer space and potentially reach a treaty on that. What could be a baseline definition in your perspective? What constitutes a space weapon on which at least 4 of you can agree to? Thanks.
Thank you. We can have one question from Dr. Nasser.
Thank you. I'm just wondering if we can find an opposite of militarization of space. Can it be civilization or civilized behavior in space? And what are the regulatory mechanisms to have a civilized and more responsible behavior from the powerful nations which are having a nuclear program. In fact, I'm asking this question to all the panelists in the backdrop of the recent explosive attacks through pagers and through walkie-talkies by the Israelis to target Hezbollah. Why it is relevant? Because it has shattered the confidence of the consumers on the technology-based whatever instruments are there, whether they are terrestrial or they are non-terrestrial or in the space. So what is the regulatory mechanism to restore the confidence of consumers, whether they are national or they are whether they are private or public sector, that these are not going to be used to target or to spy onto them? Thank you.
Dr. Ali Sarosh, your response to the questions.
I'll start with Dr. Adil's question. I will make a small comment. While on the geopolitics and astropolitics side, the gray area is very big. So the variables are large, but from a technology status point, the situation is much simpler. So first thing, there is a very there is a very clear definition for what a space weapon is. Anything that attacks a celestial asset is a space weapon. So if you have an airborne platform that is going to destroy somebody's satellite, is going to attack from space to space or from space to Earth, staying beyond the carbon line, that is space weapon. And the definition finishes there. It's very simple and very crisp. And everything falls in between. If there's a simple satellite that has no arms on it, no weapons on it, no robotic arms on it, but it has been called in to do a rendezvous proximity maneuver with the intention of deorbiting another satellite or damaging a satellite, so it's a space weapon now. So the definition as far as the space weapon is concerned is very clear. But if you do the same RPO for the purpose of doing servicing of the satellite, recovering the satellite, uploading certain data, that's not a space weapon. But if you come in and do an RPO with the intention of just monitoring what the data is being processed on the satellite, then it becomes another space weapon. So it's the intention that matters, and it's how you're going to use the space asset in the orbit. So from technology standpoint, it is pretty simple. Sir, the question of saturation of the LEO, as yet, we are pretty far off from the saturation point because the space is pretty big. But the way the near contiguous satellite constellations are growing, the problem is not saturation that's going to come out. The problem is something called as the Kessler syndrome. The Kessler syndrome is measured by a Goddard graph. The rate at which the chances of the collisions will start to increase. At the moment, the collision chances are less than 0.1% in the lifetime of a spacecraft. The moment we have all these constellations, let's say we have another 10,000 satellites in orbit. SpaceX is there, Tianfan, all have their 25,000 small sats in orbit. At that time, the possibility will jump to about 1%. That's a very big jump. So it may not be exactly that we're going to saturate the orbit. We are actually going to risk the orbit. And so the space safety concerns are going to be there. So therefore it is linked to sustainability of space operations. So we have to look at it from that perspective. Therefore, minimum separation of the orbits has to be maintained. At the moment, UNOSA and IT, all these agencies under the United Nations, they cover these requirements of minimum separation between the orbits. That's also done when you launch your own satellite. So the minimum separation must be there so that you are safely out of phase, I would say, and the risk of collision is very, very low. And out of phase with the other satellites also in the neighboring orbits. So I hope that answers. On the celestial mining, the way things are happening, as yet the extraction has not started. Habitat built up is obviously, we all know, there's a lot of research going on, how to build the lunar habitat, how to do the asteroidal mining. If at some point we are able to break through, get the cold fusion energy transported, let's say theoretically, even to Earth, at that time, the risk is going to be high. And that's why I exactly mentioned in my talk also this fact, that the nature of conflict will change. Because at that time, even celestial assets will be celestial delineation. Even hypothetical delineation will be there. I mean, NASA retrieving from lunar mission and going for asteroid and leaving the lunar assets to China actually means that China's Chang'e 6 is now there, the only rover that covers the dark side of the moon. There is only one Lagrangian satellite that covers a relay of energy from the dark side. So it naturally becomes for a very long time their piece of land. Similarly, 511 Davida. So as far as the ASAT weapons are concerned, I've already covered the definition of the basic space weapons. Dr. Nasser was asking about the militarization versus civil space. Technologically, there are 6 jobs that a satellite does: remote sensing, communication, navigation, scientific, military, RCNSM. Unless you categorize a satellite as a military satellite, otherwise, if it is a single-use satellite, a single-purpose satellite, it's going to be a civil satellite. So the opposite is precisely civil space. So we have military space and we have civil space. And the definitions are very valid. And you cannot destroy a civil space satellite because that will take you on a legal discourse for a very long time. Thank you.
I'm very precise. I just want to know.
Thank you.
I just want to know if the speakers can point out how to convince the developed states from not going into race into space. Thank you.
Thank you. Thank you so very much.
Yeah, on the cooperation side, this May 2024, we've had a very important development. Russia was planning to pull out of the ISS program, and it took the US side a long time to actually convince. And this is despite what was happening in Ukraine, because civil cooperation is so important that Russia decided to actually defer this pulling out for another 10 years. And immediately after that, we now have a seat swapping agreement between Roscosmos and NASA and the ISS consortium, in which they can take their astronauts, the Russian astronauts, aboard the American spacecraft and vice versa. And so this is a very important development, as important as you mentioned Apollo-Soyuz docking of 1975.
Thank you. Thank you so very much. So, ladies and gentlemen, let's give a big round of applause to all our speakers for this very enlightening and fruitful discussion. Mr. Dmitry Stefanovich, Dr. James Acton, Ms. Juliana Zeus, Dr. Ali Sarosh, thank you for participating in first Islamabad Non-Proliferation Conference. We are really honored and privileged to have you speak here. Thank you so very much. This brings us to the end of our session. Thank you so very much, ladies and gentlemen.
Now request Dr. Ali Sarosh to receive conference memento.